Hi everybody, in this video we're going to talk about quadrilaterals. Our learning target for this video is I can describe properties of quadrilaterals. So let's start at just looking at some basic vocabulary. A polygon is a closed plane figure with at least 3 line segments that do not cross. A triangle is an example of a polygon, a square, a rectangle, just any shape with at least 3 sides that's closed. A diagonal is a segment in a polygon that connects 2 vertices but is not a side. So take a look at this rectangle over here. That's an example of a polygon. I can connect the vertices across from each other, and that is what they call a diagonal. So there's one diagonal, and now I can connect this top left corner to this bottom right corner. And there are my 2 diagonals for that rectangle. To bisect means to divide into 2 equal parts. Bisect is like cutting something in half. So in this rectangle, I could cut it in half vertically, but I could also cut this rectangle in half like this. Bisect just means to cut something into 2 equal parts. So now let's look at classifying some quadrilaterals. A quadrilateral is just any polygon with 4 sides. There are some special types of quadrilaterals that we're going to talk about in this video. The first quadrilateral we're going to talk about is a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides of the trapezoid are called bases. The parallel sides are the sides that will never cross. In this trapezoid, the parallel sides are the top and bottom. I can mark them parallel to each other by using the same amount of arrows. The non-parallel sides of the trapezoid are called the legs. So this left and right piece of that trapezoid would be your legs. On an isosceles trapezoid, the legs are of equal length and have congruent base angles, which means those angles at the bottom are going to be equal to each other. This is our quadrilaterals family tree. Notice that trapezoid is kind of off to the left on its own. Next, we're going to look at another group of quadrilaterals called parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So that means both pairs of opposite sides are parallel to each other. So the top and the bottom must be parallel to each other. So I'll mark them with congruent arrows. But that also means the left and the right side must be congruent to each other. So I'm going to mark them each with 2 arrows. I can tell that they're parallel because they kind of look like train tracks. They would go on forever and never touch. Some other things that are important about parallelograms is that their opposite sides are parallel and congruent. So that means this top and bottom are the same length. So I can mark them as congruent by giving them the same number of tick marks. And the left side and the right side are also the same length. So I'll go ahead and give them 2 congruent marks. Another thing that's important is that the diagonals bisect each other, and one diagonal divides the figure into 2 congruent triangles. So we're going to go ahead and draw the diagonals connecting the opposite vertices to each other, and then we'll label them bisecting each other. So the diagonals here bisect each other. So here's one diagonal, here's our other diagonal. And when we say they bisect each other, that means they're cutting each other in half. So what we're saying is that this side and this side are going to be the same length as each other, and this side and this side will be the same length as each other because they were each cut in half. The next shapes we're going to look at below are all different kinds of parallelograms. All of these shapes are quadrilaterals because they all have 4 sides, but not all of these shapes are trapezoids. However, all of these shapes that we're looking at now are examples of parallelograms. So looking at this shape on the left, you should recognize that's your rectangle. A rectangle is a quadrilateral with 4 right angles. So all 4 of these angles are 90 degrees. The opposite sides of a rectangle are parallel and congruent. So using our marker, we want to mark that the opposite sides are congruent. So that means our left and our right are congruent. And our opposite sides are also parallel. So the top and the bottom are parallel. And the right and the left are parallel to each other. So I'm just marking them with the congruent and parallel symbols. All four angles are congruent and each angle measures 90 degrees. So this is a 90-degree angle, then all of them are 90-degree angles. And another thing that's special about rectangles is that the diagonals are congruent to each other, which means they're the same length, and they bisect each other, so they will cut each other in half. So if I draw the diagonals in on my rectangle, I can see that not only are they the same length, but they are cutting each other in half. Another parallelogram that's part of our quadrilateral family tree is the rhombus. A rhombus is a quadrilateral with four congruent sides. So that means all four sides are equal in length. So if this side is 5 centimeters, this side is 5 centimeters, and so is this side, and so is this side. They're all the same. Another important feature is that the opposite sides of a rhombus are parallel. So the left and the right side are parallel to each other, and the top and the bottom are parallel to each other. Their opposite angles are congruent. So I want to go ahead and draw that, what that would look like. So the opposite angles are congruent. That means this angle is the same as the angle across from it, the angle opposite. And this angle in the bottom left is the same, congruent as the angle across from it in the top right. So notice I marked the angles that were congruent to each other with the same number of angle markings. The last quadrilateral in our family tree that we're going to talk about today has some features of the rhombus and some features of the rectangle. You probably recognize that it's a square. A square is a quadrilateral that is a regular polygon with four congruent sides and four right angles. So it has four congruent sides, just like the rhombus. But it also has four right angles, just like the rectangle. So got four right angles from the rectangle and the four congruent sides from the rhombus. So it has some features of both. Some other things that are important about the square is that the opposite sides are congruent and parallel, which makes sense because if all four sides are congruent, of course the opposite sides are congruent. But it is also important to note that the opposite sides are parallel. So the left and the right are parallel to each other, and the top is parallel to the bottom. So I mark it with the same number of arrow markings to show that. All four angles are congruent because each angle measures 90 degrees. So they're all the same because each one of them is 90 degrees. This is 90 degrees. This is 90 degrees. And the last fact you need to know is that the diagonals are congruent and they bisect each other at right angles. So we're going to go ahead and draw them. So if I draw my diagonals connecting the opposite angles of my square, I should notice two things. The diagonals are congruent to each other, which means that they are the exact same length. The other thing I notice is that they bisect each other, which means they're cutting each other in half. So this half and this half are the same, and this half and this half are the same. They are also bisecting each other at right angles. So what that means is where they come together in the center here, they are forming a right angle. They're crossing at 90 degrees. So you could say those diagonals are perpendicular to each other. On page 2, we're going to talk about symmetry. So parallelograms, except for rectangles and rhombi, have no lines of symmetry. However, a rectangle and a rhombus each have 2 lines of symmetry. You can see examples below, a rectangle and a rhombus. A square has 4 lines of symmetry, and an isosceles trapezoid has 1 line of symmetry. Another important property of quadrilaterals is that if you were to take the sum of the measures of the interior angles of a quadrilateral, you will always get 360 degrees. So remember, sum just means addition. So we're saying if you added up all of the angles inside of a quadrilateral, it will always equal 360 degrees. So we can use this knowledge to find missing angles or unknown angles in a quadrilateral. So the example below says find the missing angle measures. So I see that I have this trapezoid here, and they gave me the measure of 3 angles, but not of this last one. But that's okay because I know that all together they're going to add up to 360. So I just have to find this one that's missing. So step 1, I'm going to find the sum of the angles given. So I add up those 3 numbers they gave to me and I got 255. Step 2, I'm going to subtract that number from the total, which I know is always 360 degrees. So since I have 255 degrees and I know my total is 360, I subtract that and I get 105 degrees. So I know that the value of x in this trapezoid is 105 degrees. In the second example, we have a parallelogram. I know in a parallelogram that the opposite angles are congruent or equal, and they only mark 2 of the angles, so it's a good thing that I remember that property. If this angle is 51 degrees, then that means the angle across from it is 51 degrees. And I don't know this angle, but I know that whatever it is, this angle across from it is going to be the same, so I'm going to go ahead and label it y. So step 1, I need to find the sum of the angles given. Since I only know these 2, 51 plus 51 is 102 degrees. Step 2, I'm going to subtract the sum from the total. I know that all 4 will add up to 360, so I do 360 minus 102 and I get 258 degrees. So that's how many degrees I have left over between these 2 angles that are both missing. So my third and final step is to take my answer of 258 and divide it by 2 to find the value of y. And when I did so, I got 129 degrees. So to check your answer, you should just do 129 plus 129 plus 51 plus 51 to make sure that it adds up to 360 degrees. In the next examples, we're going to use what we know about each figure to find any missing measurements. It says the perimeter of a square is 18 inches. What is the measure of one side? Well, I know that the perimeter is the distance around all 4 sides. So we're saying all 4 of these sides added up will equal 18. I also know that all 4 of these sides should be the exact same amount. So if I take 18, which is my total distance around the square, and divide it by 4, it will tell me what each side equals. 18 divided by 4 is 4.5 inches, so one side of this square would be 4.5 inches. Question number 2 says the distance around a rhombus is 124 centimeters. What is the measure of line segment CD? So they're saying the distance around this whole thing is 124. Well, I know that every side of this rhombus is actually the same. So AB is the same as BC, is the same as CD, and so on. So if I want to figure out the line segment, the measure of CD, all I need to do is take my total distance, 124, and divide it by 4. And when I do that, I get 31 centimeters. In the last example, it says the length of a rectangle is twice its width. So determine the length and the width of the rectangle if the perimeter is 258. So this is a pretty challenging problem. What you need to remember is that the length of the rectangle is twice the width. So if this is the width, and this is the width, I know the length is twice that amount. So 2 times W would give me this length right here. So step 1, I find the width, and I figure out that my width is 43. Once I know that my width is 43, I use the width to solve for the length. 43 times 2, because the length is double the width, so the length must be 86. Step 3, I just check my answer by plugging in 43 plus 43 plus 86 plus 86 to make sure it equals 258. Last thing you need to do is just write your summary. I have a suggestion below, but you can write what you want.